In this video, we are going to revise how to find general solutions and specific solutions for trig equations. Right, so general solutions are necessary when the domain has not been restricted for an equation, okay? And general solutions, you should remember, have a plus k times the period of the graph. And then we say that k is an element of integers. Okay, so in this first example, it says determine the general solution sine x equals 0,79. Now, before we calculate the solution, I want you to visually understand the solution. Okay, so what we have here is two functions equal to each other. The one function is y equals sine x. Oopsie, that's meant to be an x. And the other function is y equals 0,79. Now, y equals sine x is, of course, our trig graph, and y equals 0,79 is a horizontal line. Now, where these two graphs intersect is where we find our solutions. So here in the diagram, I have the dashed line, which is the 0,79 function, and then I have the sine graph. Okay, so if we look at their points of intersection, the solutions to that equation are the x values for every point of intersection. Now, there are multiple solutions, and since this graph's domain has not been restricted, it carries on forever to negative infinity and positive infinity. So we can never write down every single solution, and that is why we need a general solution. Okay, so what I would like to do now is just run through the steps for finding a solution of a trig function. Okay, so our steps, the first thing you're going to do is isolate the trig function. Okay, the second thing you're going to do is find the key angle. The next thing you're going to do is determine the quadrants in which the solutions lie. Okay, and we determine the quadrants according to the sign of the value in our equation. Okay, I will expand this again for every example. So after you've determined the quadrants, you are going to write a general solution per quadrant. Okay, so what I'd like to do is quickly run through those general solutions. So in the first quadrant, let me just draw the quadrants. Okay, in the first quadrant, our general solution would be the angle, and I am writing angle instead of x or theta because sometimes our angle can be a compound angle or a double angle, a complex angle. Okay, so whatever our angle is what we write in here, equals the key angle, and then we add multiples of the period of the graph of a function. Okay, and wow, you can't even read that. Let's just keep it as period. Okay, so k times the period, and remember that a tan graph has a period of 180 degrees, where the sine and cos graph have periods of 360 degrees. And then we say that k is an element of integers. That means that if I were to substitute values in place of k to find specific solutions, I can only substitute integers. Okay, right, moving on to the second quadrant. My general solution for second quadrant is the angle equal to, how do we name angles in the second quadrant? It's 180 degrees minus the key angle. Okay, then I add multiples of the period, and then k is an element of integers. It is very important that you add this k as an element of integers. You actually lose marks for it if you haven't written it. Okay, third quadrant, our general solution is the angle is equal to 180 degrees plus the key angle. And then we add multiples of the period. And k is an element of integers. the fourth quadrant, we name our general solution is angle equals 360 degrees minus the key angle plus k times the period, and our k is an element of integers. Okay, so then the final step in our solving of the equation is to solve for the angle. Okay, so solve for angle. That means that if your angle in your equation might be a double angle, so it might be 2 theta, we would still have to divide by 2 to solve for theta. Okay, right, now let's go to some examples. Right, in our first example, which is the one that we had looked at graphically, it says determine the general solution of sine x equals 0,79. Our first step said to isolate the trig function. Now here, our trig function is already isolated, so I've got a trig function equal to a value. That's what I want. I can move on to the second step. The second step was to find the key angle. Okay, and remember the key angle is found by using shift of the trig function. So this is arc sine, and then I write in the value, and my calculator will give me the solution. And angles, we round off to 1 decimal place. So here my key angle is 52,2 degrees. I just want to point something out. My key angle is always positive. Okay, we have to ensure that it's always positive. If it's negative, you've done something wrong. And I'll mention that in another example. Okay, so now the third step is to determine which quadrant I have to write the general solution in. Okay, and the quadrants are determined by the equation. Okay, so I have sine equal to a value. Now, it is the sign, the SIGN, of the value that tells me which quadrants to work in. 0,79 is positive, and sine is positive in quadrants 1 and quadrants 2. So my general solutions are going to come from quadrants 1 and quadrants 2. So in quadrant 1, I name my angle as x, that's what was given to me in the equation, it's equal to the key angle, which here is 52,2 degrees. Then I add k times the period of the graph, in this case is the sine graph, so its period is 360 degrees, and then I have k as an element of integers. Right, that's the full solution for quadrant 1, but I also have a solution in quadrant 2, so I have the angle, which is x, equal to 180 degrees minus the key angle. Then I add k times the period, where k is an element of integers, and I simplify. Okay, 180 degrees minus 52,2 is 127,8 degrees, and then plus k times 360 degrees. So my general solution from the second quadrant is that. And that is your final answer. So if you were to substitute values for k, you would find every possible solution for this equation. Looking at the second example, it says determine the general solution sine 2 theta minus 1 equals negative 0,3. Okay, so first step is to isolate the trig function. This is the trig function. So I want it on its own on one side of the equal sign. So I'm going to add 1. So I have sine 2 theta equals negative 0,3 plus 1 is 0,7. Next step is to find the key angle. Okay, so the key angle is equal to arc sine of the value, which is 0,7, and that gives us 44,4 degrees rounded off to 1 decimal place. Okay, third step is to determine which quadrants I'm in. So looking at the form of the equation where the trig function has been isolated is what I'm going to use. Okay, here I've got sine equals a positive value. So again, from the class diagram, I know that sine is positive in the first and the second quadrant. Okay, so going to the first quadrant, my general solution is equal to the angle. Now, I want to see if I've got a highlighter. Yes. Okay. This is my angle. The whole 2 theta there. Okay. So notice that I haven't done anything relating to that 2 theta. It now becomes important. Okay. So my angle is the full 2 theta, which is equal to, in the first quadrant, the key angle, which is 44,4 degrees, plus k times multiples of the period, which is 360 degrees for the sine graph, where k is an element of integers. Okay, then the final step was to solve for the angle. Now here, solve for the variable. So my variable is theta. So what I need to do is I need to divide by 2. But I divide every term by 2. Okay, so I have theta equals 22,2 degrees plus k times 180 degrees. Okay, so that is the general solution for the first quadrant. Now, sine was also positive in the second quadrant, so I'll go there. So again, I start with the full angle, which was 2 theta, equals, okay, in the second quadrant, my angles are 180 degrees minus the key angle plus k times the period of the graph, where k is an element of integers. And first I'm going to simplify this angle there. So I have 2 theta equals 132,6 degrees plus k times 360. Okay, and again I want to solve for the variable, so I divide everything by 2. You don't need to show this division by 2, but I'm showing it so that you can really see what we do, because what I see, the errors that students make is they forget to divide the period by that 2 as well. Okay, so this is equal to 66,3 degrees plus k times 180. And there is our general solution for the second quadrant. Looking at a third example, we have determined the general solution to sine x all squared equals 0,2. So I just want to remind you that that square applies to the whole sine x. Okay, so what we need to do, the first step is isolate the trig function. So I want sine x on its own. Okay, so I need to square root both sides, but it's a square, so I'm going to have 2 solutions. So if I square root 0,2, I have plus or minus 0,4472, so on. Okay, now I just want to show you. So what this means is that I have sine x equals the positive value, or I have sine x equals the negative 0,4472. Okay, now for the positive value, sine is positive in the first and the second quadrant, and for the negative value, sine is negative in the third and the fourth quadrant. So let's just first continue where sine x is equal to positive 0,4472. Okay, I need to find the key angle. So I have arc sine of the value 0,4472. That gives me an angle of 26,6 degrees. Okay, so sine is positive in the first quadrant. So in the first quadrant, my general solution is the angle, which is x, equals to the key angle plus k times the period of the graph, and k is an element of integers. In the second quadrant, my angle equals 180 degrees minus the key angle plus k times the period. Okay, simplifying the angle there, I have 180 minus 26,6 degrees, which is 153, 4 degrees plus k times 360. So I have these 2 solutions. Okay, now if I look at this other option, sine x is equal to negative 0,4472. Sine is negative in quadrant 3 and quadrant 4. Now, when it comes to finding the key angle, okay, we never include the negative. Okay, so I'm going to take positive 0,4472 in my calculation for the key angle. That means the only thing I use this negative for is to determine the quadrants. So the negative is only used to determine quadrants. You will notice that if you do include the negative in your calculation of the key angle, you will get a negative angle. And remember, in a previous example, I had said that your key angle can never be negative. Okay, so that means that our key angle is actually the same as previously, 26,6 degrees. Okay, now you could write out your general formulae for the third quadrant and the fourth quadrant, and that would be, they would all four general solutions would be correct, but it's actually not necessary. Okay, so if we look at what's happening in the four quadrants, so there are my four quadrants. My key angle is 26,6 degrees, so say that takes me there. Okay, 26,6 degrees. If I were to add 180 degrees, it takes me to the third quadrant. Okay, and in the third quadrant, my angles are labeled as 180 degrees plus 26,6 degrees. So I can actually just use the general solution to the first quadrant, and if I were to change the period that I'm adding a multiple of to 180 degrees, I would account for all the solutions in the first quadrant and all the solutions in the third quadrant. So I'm actually going to have x equals 26,6 degrees plus k times, instead of 360, 180. Okay, just because of how the quadrants work, and if I add 180 degrees, it's angles on a straight line, I get to the third quadrant. Okay, the same for the second quadrant and the fourth quadrant. Okay, so my angle in the second quadrant is 153,4 degrees. So if I go 153,4 degrees, I get to the second quadrant angle. But if I were to add 180 degrees, I'd get to the equivalent in the fourth quadrant. So instead of working through and writing a whole new general solution for the fourth quadrant, I can actually just reuse and refine my solution for the second quadrant and say, instead of multiples of 360, if I were to add multiples of 180, I would account for the solutions in the second quadrant and in the fourth quadrant. Okay, so then these two general formulae would be your final answer. A fourth and final example of finding a general solution. Here we have to determine the general solution to tan, where the angle is theta plus 30 degrees, and then plus 2 equals 6. First step is to isolate the trig function. So I want tan and the angle on its own. So I'm going to subtract 2. So I have tan theta plus 30 degrees equals 6 minus 2, which is 4. Now, I'm going to point this out again. This whole theta plus 30 degrees is the angle. Until we get to the general solutions in the quadrants, we do not touch that angle. You don't do anything to it. Okay, please. Right, so now that I've isolated the trig function, I need to find the key angle. So I'm going to use shift tan of 4. And my key angle will be 76 degrees. Then I need to determine the quadrants, and where I have isolated the trig function, that form of the equation I look at, and I have tan of an angle is equal to positive 4. Tan is positive in quadrant 1 and quadrant 3. Now, the way that the tan equations work is because the period of the graph, of a tan graph, is 180 degrees, we see that if I find a general form of a solution in the first quadrant, if I add multiples of the period, I get to the third quadrant anyway. So we don't actually have to write a whole nother general solution for the third quadrant. They are all accounted for in our solution for the first quadrant. So for the tan graph, I only need to always write one general solution. So quadrant 1, I start with the angle. Now this is where the whole full angle comes to play. Okay, so angle equals, the first quadrant is just my key angle plus k times the period, where k is an element of integers. And now I forgot to add there. Okay, now I need to solve for theta, so I'm going to subtract 30. Now I only subtract 30 from my key angle there. Okay, not also from the 180 here. So theta is thus equal to 46 degrees plus k times 180 degrees. My final answer. Okay, last example, and what we look at in this example is how to find a specific solution or specific solutions. And this occurs when our domain is restricted. Has been restricted. Okay, like in the given interval. Okay, so it says if cos x equals 0,67, calculate all the solutions for x in the interval from negative 90 degrees to 540 degrees. Okay, so looking at our equation, we have to isolate the trig function. That's already done. Next step is to find the key angle. Okay, key angle. So arc cos of the value, okay, that is equal to 47,9 degrees, rounded off to one decimal place. Now cos x is equal to positive 0,67. So we are going to be working with in the quadrants where cos is positive, which is the first and the fourth quadrants. Okay, so in the first quadrant, I have the angle, which is x, equals the key angle plus k times the period of the cos graph times k is an element of, sorry, not times, but k is an element of integers. In the fourth quadrant, I have that x is equal to 360 degrees minus the key angle plus k times 360 degrees. Okay. Now 360 degrees minus 47,9 is 312,1 degrees. Okay, now those would be my general solutions, but because the domain has been restricted, I need to find the solutions that are relevant only to the given domain. Okay, and to do that, I substitute values of k and then write down only those values of the angles that I found that lie in that interval. So let's start. If k equals 0, in the general solution for the first quadrant, if k is 0, x equals 47,9 degrees. Okay, if I substitute k equals 0 into the general solution for the fourth quadrant, then x equals 312,1 degrees. Right, what about if k equals 1? Then it means if I substitute 1 there, I'd be adding 360. So in the solution, general solution from the first quadrant, I have 47,9 plus 360, which is 407,9 degrees. If I were to substitute 1 in place of k in the general solution for the fourth quadrant, I would get a massive value of 672,1 degrees. Right, what about some negative values? Because I noticed that with just 1, I've actually gone beyond the domain there. So I'm going to go test out some negatives. If k is -1, in the first general solution, I would get x equals -312,1 degrees. In the second general solution, if k is -1, I would get -47,9 degrees. Okay, let's just also go to -2. So if k is -2, in the first general solution, x would be -672,1 degrees. In the second general solution, if k is -2, I'd get -407,9 degrees. Okay, now we notice that these are beyond the domain, so we're going to stop there. Okay, so my final answer, I'm going to write the set of numbers, sorry, the set of x values that fall within the given domain. Okay, so 47,9 falls within the domain, 312,1 falls within the domain, 407,9 does, 672 is way too big, -312 too big, -47,9 falls in the domain, and these are outside the domain. So my final answer is, and I'm going to write it from smallest to biggest, -47,9 degrees, then 47,9 degrees, 312,1 degrees, and 407,9 degrees. Sorry, curly brackets. So those are the specific solutions within the given domain.